Here you're given a circuit and the input signal, Vsig, which is here, and it asks you to see if this circuit operates as a linear AC amplifier. So the conditions for linear is that the transistor has to stay in the saturation region. So that can be brought out of the saturation region by the DC conditions, where we'll determine that in a second. Also, it can be brought out of saturation if your input is too large. So let's take a look at this circuit, and the first thing we're going to do is do a DC analysis to figure out what the currents and voltages are. So to do that, we need to describe Vsig first. Since there's no capacitor here, this is directly going in there. It's going to look at the DC value as 5 volts here, and so Vsig can be written as 5, and then it goes up by 1 and down by 1. So that's the sinusoid of omega t. We could determine that period if we want, but I'm just going to leave it generically as omega t. So this puts Vg at a value of 5, and Vs is going to be 0 since it's tied to ground right here. So we set up the equation. We assume no current going in, and then we know that the currents flowing through here are also flowing in the source. So our ID equation is 1/2, and then Kn prime W over L was given as 1 milliamp, and then Vg and S is 0, so VGS is 5, minus 2, which was given as Vt. So you square that, and that gives us a 4.5 milli. So now we need to check that our conditions for Vd is greater than Vg minus Vt. So Vd is going to be Vo, and we have a plus, and then this goes to a plus minus, so we're going to have a minus 1K times the ID of 4.5 milli, and that's going to give us Vd. So this is a plus 8, and then a minus 1K times that current, and that gives us 3.5 volts. So the comparison of 3.5, and then Vg was 5 minus 2 is 3, does indeed have it in saturation. The other thing we need to check is that VGS is greater than Vt, which it is, and so this is on. So we have verified, yes, the DC values do keep it in saturation. Now what happens in the AC? So for AC, we need to redraw the hybrid pi. So we redraw this circuit to be connected in the hybrid pi. So Vsig is your input, and then Vs is ground. The drain side of it has just 1K, and then this is going to go to ground, so you have 1K to ground. We also need to know the parameters for GM, and so GM is VGS Km prime W over L times VGS minus Vt. So that gives us 3 milli for GM. Analyzing this, we know the current is flowing in this direction, and so we're going to get a negative GM1 VGS1 times 1K. So that gives us a minus 3, and VGS we know is the G minus the S, and in this case it's Vsig minus 0, so just VGS is Vsig, and so that gives us a minus 3 Vsig. So the Vout total is going to be the DC value of 3.5 volts, and then a minus 3 times the input, which is just sine omega t. So we center it around 3.5, and it's going to go up by 3 to 6.5 and down by 3 to 0.5. So since this is an inverting amp, when the input is 6, we get a lowest output of 0.5. So for that condition, that means the output, which is Vd, is 0.5. We need to compare it to the VGS minus the Vg minus Vt, and VGS is going to be the high, which is 6, minus 2, and so that's going to be 4. But that condition means that the Vd is less than, so this condition is not saturated when it goes to the low. We can also check the high value and see if it pulls it farther out. We can't go higher than 8 volts, which was our given supply voltage. At 6.5 volts out, we are not reaching this, but then the input could be pulling us out of saturation. So the input's going to be lowest at 4, and your output is 6.5 in those conditions. So 6.5 is the VDS, and then VGS is 4 minus 2, which is 2. So this is indeed still saturated, but it doesn't stay saturated the whole time. So we are going to get distortion, and this would therefore not be linear amplifier. Thank you for watching.